All right, welcome back to the 1MO3 videos. So hopefully in the last video, you have already looked at the 7 questions that I asked on the Material Taboo game. So I'm going to review the questions. I'm going to review the material now. And then have you decided what material that is? It's silver, it's heavy, it's not magnetic, and it's often used as a kitchen sink, okay? And the answer is stainless steel. Give it a pause for yourself. Hopefully you got the right answer. And I'm going to show you right in front of me. I'm going to review. This is the materials. And if you look at my screen right now, camera right now, you should be able to see that this is the material that I've chosen. Now, so question 1 was how heavy this material is. Steel is on the heavy side of the spectrum, as I show you. Question 2 is actually how loud the pitch is. So if I drop it on a coaster, compared to other material, it's actually quite loud. And then there's one more that is important, is it's just not bouncy actually. And then if I touch it, it actually feels cool on my hand. And then there's one more that is important that I will show you. This right in front of me is mild steel. This is stainless steel. If I put the fridge magnet in front of the mild steel, it can pick up the mild steel. If I put the fridge magnet onto this particular stainless steel, I cannot pick it up. Similar argument, I cannot pick up aluminum or brass or any other material. The only material that I can pick up is mild steel, which is ferromagnetic. So you might want to think about why that is the case. So this bring us to the learning objective to this particular game. So, like I said, the answer for this Material Taboo game is stainless steel. Hopefully you got the right answer. I hope this particular education gives you a sense of what material property is. At least I've shown you that if we have balls made out of same diameter, but made out of different material, they have a whole bunch of different characteristics. If you just look at this graph, you can see that they are very colored. They're very different color. They have very different color. So why is that the case? And they're different. They have different weight as well. What caused that? Probably related to the atom. But I want to really showcase that you actually already have a sense of what material property is. Previously, qualitatively, in your daily life, you always deal with how heavy an object is. What's the pitch? What's the sound? What's the touch? What's the feel? What's the texture? If it's a food item, you can even taste them. All these sensory are related to performance of that particular ball. But then when I remove the geometry, so remember, performance is always a function of geometry and material property. When I take away the geometry component of that structures, what's left is the materials. And by evaluating those balls one by one, we basically have material property. So for example, how heavy the ball is related to a general material property called density. So in this course, you actually learn how to estimate material properties such as density based on the very fundamental first principle, looking at how atoms are being arranged. And by doing that, we can calculate the density from first principle. The second question is high pitch. So soon you will find out that a pitch of a material is related to its vibrational frequency, which is related to the wave speed of the material when information are traveling. So that's actually related to the stiffness. So you can imagine if I have a tuning fork made out of very stiff material versus very flimsy material, the pitch of the tuning fork that is very stiff is higher. And so this is related to Young modulus. how bouncy is the ball? That's actually related to another mechanical property, that's toughness. And in this course, we will learn a lot on the mechanical property as well. Now, this one is the interesting one. If I hold it on the hand, will it feel cool? So all these balls has been sitting at room temperature for a very long time. When I first touch it, yet some feel like room temperature, some feel like it's cool. Why is that the case? The reason is that my body temperature is not room temperature, it's 37 degrees Celsius. So I'm constantly losing heat. So the material that feel cool are actually not related to how cool they are, but related to how fast they can transfer heat. And so in this course, we'll learn another property called thermal conductivity. That's a thermal property. Now, this is the other interesting one. Does it stick to magnet? That's magnetism. That's related to electromagnetic property. And we'll talk about that. And then what's the color of the ball? That's related to optical property. In this course, we will not talk about the optical property. I hope you can appreciate that this has a fundamental behind it, and different material have different color because of how atoms are being arranged, how electron structure are being arranged, and by doing so, it interact with a light wave differently. Okay. So we were talking about our answer to be stainless steel. So just to give you an idea, stainless steel is relatively heavy with relatively high Young modulus. One thing that we have already mentioned, the thermal conductivity of stainless steel is high compared to other material. That's why when you touch fridge, the fridge door, you'll find that it's relatively cool, right? Or maybe you touch the sink and it's relatively cool. It's silverish. This is related to band gap. And the reason why we chose stainless steel for kitchen sink is because it has really high corrosion resistance. And something very interesting about stainless steel compared to, let's say, mild steel, they are all made out of iron, but we put carbon as well as other impurity into the iron matrix. So, for example, stainless steel, we put some nickel and cobalt into this iron. By doing so, we actually create a new crystal structure. So you will learn about that. So these are basically atomic arrangement of this steel. So this particular one is typical mild steel. They will stick to a magnet, and it's because of the crystal structure. When you put nickel and cobalt into iron, and if you put enough of that, it will change the crystal structure to another one. So this one is called BCC. We'll learn more about that, so don't worry about it for now. And this one is called FCC. So the atom arranged differently. And by doing so, you change the magnetism. So hopefully this gives you a sense of what material property is, okay? By removing the geometry, you can actually see one material different than the other. In the software, where we'll introduce you to this learning tool, we have introduced, you can actually download the ANSYS granter, or you can go to the virtual machine and use the ANSYS granter. This is a software that have 6,000 materials inside, and each have a material data sheet that talk about the material property. It also talks about typical use of this material. So if you are a designer, this is an incredibly useful tool because you can quickly learn the materials. You can quickly characterize this material in comparison to another material, quickly determine if this material is suitable for your performance or application. When you click on this software, you also find information tab where you can click on each individual material property, and it will talk a little bit more about the science behind it. So this, I would say, is a supplementary learning tool that you should use outside of your classroom. Okay. So with that, I hopefully will give you an idea of what material property is. Like we said, performance is always related to material property and geometry. So a material property if you look at the definition, is an inherent behavior of a material that does not depend on its size. So, for example, optical property does not depend on size. It is also called an intrinsic property. In contrast, what you have learned, maybe perhaps in your high school, like mass, weight, these are called external physical property, and they are physical attribute of a material that depends on its size. To give you a very simple example, let's say mass versus volume and density. Mass is an extensive property. It changes with its size. The bigger the mass, the bigger the volume. Okay. So, for example, if I have 2 kilograms versus 1 kilogram of rice, 2 kilograms is heavier. But at the same time, the volume of that 2 kilograms of rice will be bigger, right? And so, what is intrinsic property? Intrinsic property does not depend on its size. For example, density. Density is mass divided by volume. And when you divide one physical property with geometry, you often result in intensive property. And so, for example, we talk about a bag of grain of rice. We have 1 kilogram versus 2 kilogram. The volume will change by a factor of 2. So if you measure the mass over the density, over the volume, you'll find that the density of 2 bags of rice will be identical. And this is incredibly useful in engineering. In engineering, we often want to measure intensive property. And the reason why we want to measure that is because by doing that, we allowed us to distinguish one material over another, and so that we can select the right material for performance, for a device. For example, if you build a car and you want to design the chassis, you want to know what materials to be used there. You don't necessarily want to know the weight of that structure, because that depends on the CAD drawing that you have. Depending on the geometry that you have, you can manipulate that. But the fundamental question of what materials should you choose depend on the material property. So in this course, we will introduce you to a set of material property and how they arise. Okay. Finally, one more question that maybe we can think about is the y-axis of this graph. So in the x-axis, we talk about weight versus each of the ball. So that's because of the normalization of size, which is volume. Each of these balls have the same volume. So essentially, what we have said is that the x-axis are now equivalently saying density. So what is the y-axis of this graph then? Well, you might want to think about it. I will reveal the answer now. But styrofoam is weak, not soft. Steel or copper stiffer. And the answer is Young modulus, which is stiffness. Okay. So elastic modulus is the extensive property form of stiffness. And so in this graph that I've shown you, this ball game is actually a 2D graph of a material property chart. It's a physical model of that material property chart. In the x-axis is density. In the y-axis is elastic modulus. And these things actually can be translated back to the program that I've shown you, the ANSYS grantor. And here I've shown you the equivalence graph of density versus Young modulus in quantitative form. And you can see each of these material lying there relatively similar to the physical model. What is good about this is you can now see a whole picture of a design space where you can use to select one material over another depending on your application. To give you an example, later on in this lecture series, I will talk about selecting the right material for a bicycle frame. And a bicycle frame, you might want low density and you might want high stiffness. And so you might want to go to the top left corner. And so by evaluating the ratio between the young modules and the density, you can choose the appropriate materials, okay? And so foam might be very lightweight, great, but you don't use foam for a bicycle frame. Why? Because it's not very stiff. Copper and brass are very, very stiff, but they are very heavy. So maybe you don't want that, okay? So that's hopefully give you an idea and appreciation of what material property is. So just to recap, there are many types of material property that are available. There are general property, mechanical property, thermal property, electrical property, magnetic, optic, and environmental. We will talk about the first four of the property in this particular course. And just to give you an idea, each of this property could be drawn as a different type of material property chart, and they will look very different. And so depending on your application, you might want different type of combination of property, and you might want to use a different graph to choose the right materials. So this particular answers granted tool will be very useful, and I will say it's your friend to learn about material science, right? Thank you very much. I will see you in the next video.